Students, welcome back. This is the part 2 of lecture number 1. So far we discussed about basically different kinds of tech giants in AI, as well as the last part of my means at the end of the section, the portion 1 of lecture 1, I discussed about how conventional materials are discovered. This is the last slide which I used. So let us see how AI can change this. Can I have a new paradigm? So if I have to put it in one perspective, this is taken from a paper by Agrawal in 2026. When we started learning science, we could have started sometime in 1400 or 1500. So first we have something called empirical science. We never understood what is happening. We only have empirical rules, like sun, earth rotated around sun in 365 days, moon rotated around earth in 28 days. Why these numbers? We never understood. So first paradigm we call as an empirical science. And then 1600 onwards, Galileo, Isaac Newton and many other scientists which you have heard came and put solid foundation on these concepts. So from empirical science we came into a second paradigm called model based theoretical science. The classical one is the first law of thermodynamics, which is written here. You can see delta U is equal to Q minus W. Q is the heat, W is the work done, and delta U is the internal energy change. And that changed many things in the history of science. Then came quantum mechanics and many other stuffs. From 1950 onwards, computers came into our life slowly, and we thought something can be done. As I told you, the material science deals with structure, and we want to predict properties, and we make the materials by different techniques called processing. Finally, when you put everything together, we are interested to know the performance of the system, correct? So when you take exam, it is your performance what is important, not anything else, right? So your performance depends upon how much you have learned, how much you have studied. So therefore these are all like structure, how much intelligence you have is depends on properties, right? And how you study, how much you study, that depends on your processing, right? So therefore this is the 4 pillars of material science. So from 1950s we came to a new domain or new paradigm called computational science or simulations domains. We started simulating things from 1970s, 1980s, and from 1990s and 2000s simulations took over our life. Many people actually worked on these. There are many of my friends, they have done PhDs on simulations also, material science. But subsequently 2000 onwards something else happened. Before you do that, let me tell you how do you statistically screen out a material. First you select a candidate, synthesize it, make it actually in your lab, analyze it. Analyze means do X-ray diffraction, SEM, these, that, so many experiments. Test for the effectiveness. If it works, it's fine. If it doesn't work, throw it up. Again you go back. That is how the traditional material design or discovery happens. We are going to change because of AI to virtual screening. Why do you need to use such a long list? So in a virtual screening, what do? You see here, because of computational material science, you screen a new candidate, select a new candidate, screen in what is known as a situ. This is the first loop. Here actually you can go and back and forth to understand whether it will work or not. You can actually make the material in the computer, test its properties, everything you can do that before you synthesize. So that reduces number of candidates to be synthesized, right? So here I am showing you that initially you have a large number of candidates, you basically use computational tools to screen it down, reduce the number, so that we can test it using experiments. So that is what is called a virtual screening of materials. What is the advantage of that? Well, this gives you an idea of high throughput screening. So in addition approach, you can start with many, design space is very big. you start something here, something there, something here, your real solution is here. So, chances of hitting this target is low, right. So, you have to employ large number of people, try from different ways, so that you can reach the solution. In high throughput screening, what do you do or approach? Basically, you have a large number of systems and then you measure using computational approach each of these, right, their properties, everything you measure. Finally, one of these is solution. This is possible nowadays because of high computational power, but this also requires a lot of time and efforts. Why not use a targeted design approach? Why not select a path which will be leading to a solution? So, instead of traveling from here, traveling from there, traveling from here, I simply travel from starting point in a targeted manner, so that I can reach the solution. That is what is your machine learning and deep learning can provide you. Then you have a problem of product versus manufacturing attributes, right. Product attributes will be high density, hardness, toughness, chemical durability, and manufacturing problems, viscosity, glass transition temperature for glasses, liquidus temperature for alloys. Then you have a CO2 emissions, cost, many other factors which are not the end products. How to balance these two? That is another challenge, right. When you manufacture something, you have many other problems. CO2 does not come in picture when you are testing a lab. CO2 comes in picture when you are making things in real life. So, how to manage CO2 is a big challenge, you understand. Cost obviously important challenge because you are going to sell it. So, therefore, these aspects must also be taken care. To give an idea, let us talk about glass, right. Glass has contains sodium, calcium, barium, silicon dioxide. Some cases glass also contains fluorine, fluoride glass, phosphorus, boron. Okay. If you look at combine all these elements, you have 10 to 10 to the power 50 possible glass composition. This is just like stars in the sky, but only 400,000 glass compositions explode over last 6,000 years. That is very small compared to 10 to the power 52. So, many more can be explored, but nobody explored because experimentally is not possible in your lifetime. That is why if you want to design a new glass, let us say your main objective is to improve the toughness. When glass is brittle, you throw a stone, it will break. You want to make it toughened glass. So, how do you do that? You can simply first change the composition, that is one aspect. You can use SiO2, B2O3, L2O3, P2O5, Na2O, K2O, calcium oxide, magnesium oxide, many things possible, available. And what are the constraints you have? You have a constant of viscosity, glass has to be very viscous, right. Liquidus temperature, it cannot be very high liquid temperature, cost, CO2 emission, etc., etc. Can I build a model using all these aspects? That is what the key question is. That is why the big data and artificial intelligence comes into picture. And big data means zettabytes of data. It is just like a 1 followed by 10 to the power 21 zeros, 21 actually, 10 to the power 21. That is all is called zettabytes, very high. This is taken from audio. Okay. So, we can use this instead of doing experiments for glass also and do that, right. So, hence I came back to the important paradigm again taken from Agarwal. It is that from 2000 onwards, we have a fourth paradigm called a big data paradigm or data driven discovery paradigm. So, you have a first empirical science paradigm, we graduated to model based theoretical paradigm, then in 1950s onwards, we have a computational science paradigm, and now we are into a data driven paradigm. Am I clear? So, that is the key aspects of the change of paradigm. We are into a data driven paradigm, how to make it useful. That is why we can use deep learning. When you have huge amount of data, you can use neural networks, deep learning to understand how glasses, best glasses can be formed, top glass. Many of mobile phones have, top thing is a glass or sorry bottom thing is a glass, if it falls on something hard object, it does not break. That is what is called a toughness. and it is made of a glass, metallic glass. Okay, mobile phones casing, it's shown here, some of these things. Okay, so that's what is taken from Kristen. He is one of these giants in the material informatics. Okay, so let's come back to now what is machine learning, and then we'll go to deep learning. So first, let's say I have a function which is consisting of variable x1, x2, x3, x4 like that, and we want to interest to know what is the output y, correct. How do you do it? Common aspects, we simply formulate a function between y and this x1, x2, x3, x4, x5, whatever. So that functionality, that means that functionality first we figure out, right. First you can actually do that. Let's say P is equal to m into a, Newton's second law. P is the force, m is the mass, a is the acceleration, right. Or gravitational force G or F is given by G multiplied by m1 m2 by d square, correct. So once you know these relationships, which is thankfully discovered by Sir Isaac Newton, we can find out, right, easily. If I know the mass of the two objects m1 m2, if I know the d, distance between the two objects, and I know G, the gravitational constant, I can find out the force acting between two objects, right. That is called the gravitational force. So that is the standard way of human based calculations. That is what is called human based calculations. What AI do? AI or ML use data. You have lot of data, right. These are your data. From the data you find out some unknown relationship between y and these variables x1, x2, x3, x4 dot dot dot, and once you find out this unknown relationships by some kind of a modeling, okay, then you can predict y for unknown values of x1, x2, x3 dot dot, okay. You can do that. So this is the difference between human and machine. We are trying to make the machine learn from the data, and once it learns the correlation between these variables, then it can predict something. That is in a nutshell is what is called a machine learning, right. But deep learning is different. It is a specialized subset of this machine learning which uses multi-layered artificial neural networks to mimic human brain. That is the difference between machine learning, what I just now discussed, and you can learn more from my earlier course also, to do with deep learning. It is a subset of machine learning, but it uses multi-layered artificial neural networks. It uses computers to automatically learn from the vast amount of raw and unstructured data. Please look at these words, raw and unstructured data, artificial neural networks, and it learns without need of a manual feature programming. Machine learning requires some manual feature programming, but deep learning does not require that. So this is the real definition of deep learning. Now how does it work? It uses neural networks, it extracts the variables itself. You do not have to do it by the human intervention. It extracts the features of variable itself, and it also improves the predictive capability by continuous adjustments of these variables. Then if you keep on changing these values of the variables or their factors, so that it can achieve very high efficiency. What are real level applications? I have already given you some of these in the first part of my lecture. The best example is generative AI, that is large language models or AI image generators, computer visions, natural language processing, finance, stock markets. What are the key components of this? Obviously, it requires large data, big data, massive data sets to train the model accurately. Similarly, when you use massive data sets, you need to use high computational power or high performance computing, what is called HPC. So, these are the key components of any deep learning. This slide is very important, you should go over nicely, so that you understand everything very clearly. Okay. So, since we are talking about structured, unstructured data, let me just clarify it carefully to you, so that you do not forget it. What is structured data? It has a specific format, like fixed schemas, tables, comma separated, CSV formats, spreadsheet like Excel sheets, whatever you use. Examples are phone numbers, dates, transaction IDs, product SKUs, sensor readings. Many times for the electrical meter reading, people come, they take, that's basically nothing but a structured data. It can be stored in relational databases, data warehouses. It can be processed using sequential query languages for immediate queries, easily analyzed by basic business intelligence models. In comparison, deep learning uses unstructured data. What are these? The format can be raw, native formats with no predefined structures like tables, CSVs, like emails, audio video files, social media posts, many PDF documents. It cannot be stored, it can be stored in NoSQL, SQL databases or data lakes, very large amount of data, and it can be processed using advanced machine learning tools like NLP, computer visions or any other techniques. So, this is the main difference. Let us see some of the examples. This is an example of a telephone directory of our IIT Kanpur. You can see the important numbers of telephone directories are nicely presented here. Okay, on the left side names, right side your phone numbers. This is called as structured data. You can also have mark sheets. This is marks of students in an exam. You can see absent, then somebody has got 10, 12, 19, 20 out of 18, 20 actually. You can also have a data from sensor, you can see here basically from different sensor data, very fine. Oh, sorry, this is a not sensor, this is basically SAN data, and this is what is your, this is XRD data. XRD you will have 2 theta versus intensity, right. So, 2 theta values are 0 to 0.096, I am only showing a small part, and this is intensity data. This is also a structured data. On right side you have a sand data, for a fine sand, very fine sand, coarse sand. After sieving, you do a sieving experiments, so you can get this data. Deep learning uses unstructured data, like what, video files. Okay, there is a video here. I don't know whether it operates or not. Okay, it operates. You can see here. There is a video. This is my introductory video. Can I get information out of it? You can also have emails. You can take emails, and then audio files, sound. Okay. You can have sensor data, which is shown on the right side. You can see sensor. This is time, date, time, and some sensor data. Okay. Okay, it is taken from labs. Then you can have a server website data, images, social media post. All these are unstructured data. Please keep in mind that. So, you must know what is structured and unstructured data very well. So, before we go into deep learning, let me introduce you the giants of deep learning. 2018 Turing Prize is basically given by CEM, Computation Machinery Society. 3 people, Geoffrey Hinton, Joshua Bengio and Ian LeCun, for their discovery in the development of neural networks. In 2024, 2 years ago, Nobel Prize awarded to John Hopfield and Geoffrey Hinton, again for the contribution in the AI, basically deep learning methods. So, this gentleman has started this work in 1950s, so that today we see the output of that. That tells you one thing, that whatever you are doing today may not find application tomorrow. It might find applications once you become very old. See, all these gentlemen, they are old enough to see their discoveries seeing the real applications. So, do not be afraid that whatever you are discovering today may not find application in future. it will always find some applications. To give you a detailed perspective difference between ML and DL, ML is a subset of AI and DL is a subset of ML, remember that. ML uses small set of data, DL uses large set of data, and ML requires intervention of the human. DL learns from its own environment and past mistakes. ML requires short time training time, often lower accuracy, but DL requires long training times, higher accuracy. ML requires makes small simple calculation, DL can make highly nonlinear complex calculations. We will show you that. Can train on a CPU, central processing unit, but it requires GPU like graphics processing units to train for these, because they are using images, video, lot of other data, that is why. So, examples to give you, all of you have probably know about additive manufacturing, right. It is a very important technique now. We are making many objects out of additive manufacturing. You can use DL to design parts, sensors, monitoring the things, microstructure properties, defects like ports are very common in additive manufacturing, and also residual stress, because when you build an additive manufacturing part, it develops residual stress. You may soon have additive manufacturing specs, additive manufacturing shoes, which will be in the market. Second example is, I have a microstructure, which is image, right. You can see some particles here, right. This is cesium chloride particles, as far as I know. Can I predict its physical, mechanical, functional properties from this? Question is yes. That is why it requires the concept of deep learning. So, in a nutshell, deep learning equates to three sets of data: sequential data. This is a kind of data where order matters. Set of sequences like text streams, audio segments, video clips, correct, or time series data. Time series data means as a function of time when you are recording a video or recording audio, that is what it is. Text streams also, you are writing something in WhatsApp or chat bots or whatever, you can use these text streams. Then you can also have image or 2D data. A digital image is made up of matrix, which is a rectangular array of numbers, symbols, expressions arranged in rows and columns. We will talk in details about this. These are 2D array of numbers like pixel, voxels, bit depths, the 4 essential characteristics of fundamental parameters, right. And last one is a tabular data, which is, we all know, I have shown you some of the examples as the rows and columns of data. So, this is a very important slide. Performance of any model depends on the data. Machine learning models are good when amount of data are less, but deep learning model outperform machine learning, you can clearly see, when data are large, much large. That is why you need to use a large volume of data to train your deep learning models. That is why this text, images, videos are widely used, because that contains huge amount of data. So, this is what is the break even points. You can see here that there is the crossover. So, below this machine learning performs better, and above this deep learning outperforms the machine learning models. So, when you have less data, please do not try to use deep learning. First try to get more data, so and this can be then used for deep learning models. What is the workflow of deep learning? It is simple. First you have to understand the data and pre-process. This is very important. Collect, understand the data and pre-process. The real world data, you have to first visualize, remove the outliers, make the annotations, processes this data, and that is step 1. Step 2, actually you develop a DL model and train the model. It can be generative model, discriminative model, or hybrid models. Task predictions can be prediction, detection, classification can be task. There are many models like multi-layer perceptance, CNN, RNN, reinforced neural network, GAN, autoencoders, DTL, deep transfer learning, or other models. Okay? And the step 3, you do a performance analysis. So, how the model is doing the job, interpret things, and all these aspects. That is what is step 3. So, I will not get into details of again comparison into machine learning and deep learning. This is for you to study well. Here each and everything is depicted. Important thing is that deep learning requires large data. I told you it takes more time to train. It uses neural network compared to other statistical algorithm for machine learning, and it is relevant. It can extract the features or the parameters. The deep machine learning requires human interventions, and it can handle, deep learning can handle more complex problems and interpret them. Deep learning requires GPUs and high performance computings. Machine learning can be done in real small computers. So, what are the applications? First is computer visions, object detection recognitions, image classification, image segmentations. Secondly, natural language processing like automated text generation, language translation, sentiment analysis, speech recognitions, reinforcement learning used in gaming or robotics, control systems everywhere, we can be done extensively. What are the different models we use? Lot of models, all are based on neural networks, artificial neural networks, convolutional neural networks, recurrent neural networks, autoencoders, deep belief networks. There are many such models which we will discuss one by one. Okay? So, it depends on data. First thing I told you, key properties, if I have to talk about deep models, it highly depends on hardware. Hardware actually requires large computational powers. If you do not have, you cannot do good deep learning models. It does feature engineering itself. It uses time and efforts to construct the features or the parameters which are required for modeling. Model requires extensive training to execute. It's black box. That is the perceptions of the people. That's why it took a lot of time for Joshua and others to be recognized by Turing and Nobel Prize. So, let me stop here. So, we will start from supervised and unsupervised learning business in the next lecture, lecture number 2. Hope you understood the various features of the deep learning as compared to machine learning. You must not get confused with machine learning and deep learning. This course is primarily on deep learning. So, we will start talking about neural networks in the next lecture onwards. I will start from very basics, how the neural network can be built up. Thank you.